My name is Richard Hill, and this class will introduce you to a Y-DNA test known as Y-DNA testing. The Y chromosome has a unique inheritance path. That path is narrow, passing down a single line in your family tree. Your father got it from his father, who got it from his father, and so on. Here's the power of Y-DNA testing for genealogy. If two men match each other on a Y-DNA test, their direct paternal lines must intersect in a common male ancestor. But we don't know how far back that was. It could be recent, or it could be many generations ago. Here's what Y-DNA testing can do for you. You can confirm descent from known male ancestors. You can find genetic relatives who share a male ancestor in the direct paternal line. You can find the surname of a male's biological father, especially for adoptees, donor-conceived people, and so on. You can define your paternal haplogroup to trace ancient geographic migrations. So who to test? Obviously, you need a male. If you're a man, you can test yourself. Yet many women use Y-DNA testing by finding a suitable male subject. That could be your father, your brother, your father's father, a brother of your father, or a son of your father's brother, and so on. Where should you test? The obvious choice for anyone new to Y-DNA testing is Family Tree DNA. They have the world's largest Y-DNA database and a broad range of Y-DNA testing options. They also have more than 10,000 DNA projects that you can join. Y-DNA testing was introduced over 20 years ago. As processing costs have dropped, more and more markers have been tested. Some testing levels are no longer offered. The 37 marker test is the minimum today, and it's adequate for many people. The 111 marker test is better for serious genealogists. Finally, Big Y700 is an advanced test that I will say more about later. Each marker defines a location on the Y chromosome where they count the number of STRs, short tandem repeats. The DYS number identifies the marker, and the number below each marker reports the number of repeats at that location. The number can mutate between one generation and the next. For example, a 17 could go up to 18 or down to 16. Genetic distance is an important concept in Y-DNA testing. In this example, one man has 25 repeats on the leftmost marker, and the other has 24, for a difference of 1. On the rightmost marker, one has 17 repeats, and the other 18, for another difference of 1. The sum of these differences is 2, which is the genetic distance over this range of markers. Family tree DNA has different thresholds for what they consider to be a match. At 37 markers, a genetic distance of 4 or less is a match. Someone with a genetic distance of 5 will not be listed. At 111 markers, the threshold expands to 8. In general, the smaller the genetic distance, the more likely the common ancestor is to be discoverable. You can start with 37 markers and upgrade to more later, but don't expect more matches. You probably won't see any. And even if you do, those new matches can't be very close. The genetic distance must be at least 5, or they would have shown up as a match at 37 markers. The reason you might upgrade is to see which of your matches are actually closer. For example, if you have 4 matches at 37 markers, all with a genetic distance of 2, An upgrade to 111 might, for example, break them out into genetic distances of 2, 4, 6, and 8. Family tree DNA provides many ways to look at your Y-DNA test results. Here are the buttons to explore on my Y-DNA summary page. In this brief class, we can only cover some highlights. Here is my Y-DNA matches report for 111 markers. I have covered the 6 names for privacy. Those covered with a green bar have the same last name as my birth father. Those with a blue bar have other surnames. I can also view other marker levels such as 37, where I have 22 matches. My matches are sorted here by genetic distance, with the closer matches at the top. You can sort by other columns and apply various filters to your results. Clicking the name of a match brings up a profile page with additional information, most notably an email address. By contacting matches, you can work together to discover your common ancestor and possibly extend that branch of your family tree. As I noted earlier, Y-DNA testing cannot tell us how far back a common ancestor lived. At the right, you can click on an icon to view a time predictor for any match. That will attempt to narrow the time range through what they call a tip report. This report looks at individual mismatches and uses the mutation rates specific to each marker. Here's how to read it. The probability that this match and I share a common ancestor within the last 4 generations is 65%. Within the last 8 generations is 95%, and so on. I changed the report to show 1 generation steps for 2 of my matches. The report on the left compares me to a match with a genetic distance of 3. The one on the right has a genetic distance of 7. I use the 85% point as a rough working assumption. That puts the common ancestor on the left within 6 generations, and the one on the right within 11 generations. You can see why you should focus first on matches with a smaller genetic distance. Here's something you need to understand about Y-DNA testing. There is a wide variation in results. Just look at these examples from testing I have done. On my 22 matches at 37 markers, 10 of them have the same surname as my biological father. Cousin in my adopted family has 30 matches at 37 markers, and 22 of them match his father's surname. My wife's brother has 203 matches, and not a single one has the same paternal surname. A cousin of my wife is still waiting for his first Y-DNA match of any kind. Family tree DNA also reports the haplogroup of each match, with names like R, M269. So what is a haplogroup? Think of one huge Y chromosome tree of all the human males who ever lived. The tree started in Africa at least 200,000 years ago and began dividing into branches. The mutations that mark the branches are abbreviated SNP and pronounced SNP. We call those branches haplogroups. STRs, on the other hand, are like the leaves on the tree. They trace more recent splits and determine our genetic matches on a typical Y-DNA test. Using only STRs, family tree DNA will estimate your haplogroup. For me, that was M269. 2 of the autosomal DNA tests also look for haplogroup-defining SNPs in the Y chromosome. 23andMe measures me as L21, which is several steps more specific than M269. Living DNA takes me downstream another step to DF13. A great site for European population genetics is Upedia. This diagram starts with L21 and goes downstream from there. The map shows how common L21 is in Europe. It points heavily to the British Isles, but it is also common in France, Germany, and other parts of Europe. We can trace our paternal ancestry more specifically with big Y 700. Let's focus on the section of the tree outlined in red and blow it up larger. At the top you can see L21, measured by 23andMe, and DF13, measured by living DNA. I did big Y 700, which checks tens of thousands of SNPs and takes me many more steps downstream on the path marked in yellow. It ends at my current terminal SNP of A545. My paternal ancestry is clearly rooted in Great Britain. Another thing you can do with your Y-DNA results is join a group project. Family Tree DNA sponsors thousands of them, and it's an opportunity to work with others to explore your genetic heritage. Some may combine DNA results with genealogy. Membership is always free, and you can join or leave at any time. These groups are run by volunteer administrators and supported by Family Tree DNA project tools. They tend to focus on surnames, geographic areas, or haplogroups. When you join a surname project, an administrator will probably place you in a group of similar Y-DNA results. Within a project, tables like this one show you exactly where markers differ and how they differ. The maroon-colored marker names at the top are known to be fast-moving markers, likely to change more frequently. Here's an example of a geographic project. It's early Chesapeake settlers, and the white pin shows where my earliest known paternal line ancestor was born in Virginia. In this map, the other pin colors are used to distinguish haplogroups. All the brown pins are in haplogroup R. I can select any pin and see who it belongs to. There are also haplogroup projects. Since I am under L21, this is one that I joined. They try to track all the downstream mutations. As you can see, this can get extremely involved. In my case, I am under one of the yellow boxes on the right side. Here's an image I shared earlier, the tree of all human males. The prevailing assumption had always been that SNP mutations could only define branches of a tree that split thousands of years ago. You needed STRs to identify recent splits into surnames and families for genealogy. Tests like Big Y have changed that by finding smaller and smaller branches. In December 2021, the Y-DNA tree at Family Tree DNA hit 50,000 branches, and the growth continues. Now people are finding ways to use all this additional SNP data for genealogy. There are and have been other companies doing Y-DNA testing or mitochondrial DNA testing. This volunteer-run nonprofit called Mito Y-DNA lets anyone upload such data for comparison with others. Once you get your results from Family Tree DNA, I encourage you to visit the Mito Y-DNA website and upload your data for an even wider comparison. Here's just one interesting feature of the Mito Y-DNA site. It picked up my terminal SNP of A545 from my data and plotted the migration path of my direct paternal line all the way from Africa to England over various color-coded eras. They say A545 branched off in medieval times. That would be in the 1500s or earlier. While this may not be a big help yet genealogically, the explosion of newly discovered SNPs will keep defining more recent branches. Y-DNA testing is especially important to me. When I sent in my sample in late 2006, I had no idea that I would be a pioneer. I became the first known case of an adoptee identifying birth family through a genetic genealogy DNA test. You can read the whole story of my decades-long search in my book, Finding Family, My Search for Roots and the Secrets in My DNA. It's available in print, Kindle, and audiobook formats at Amazon.com and other booksellers. To learn more about DNA testing, visit my website, DNAfavorites.com. You can see the menu of pages in red. Starting near the top and moving down from one page to the next provides a great overview of genetic genealogy today. Along the way, you'll find more than 150 links directly to the most useful DNA testing resources. In addition to my DNA Favorites website, I have a DNA Favorites Facebook page. Also look for the name Richard Hill DNA on Twitter, LinkedIn, and Instagram. If you belong to a genealogy or other group that would enjoy learning more about DNA testing through a virtual or in-person presentation, contact me through email, richardhilldna@gmail.com. This concludes the class on Y DNA testing. Thank you for watching.